Hello everyone, welcome back to my channel. My name is Piyush and this is video number 26 in the series CK 2024. I know we have come a long way, so thank you for your support till now. And in this video, we'll be looking into network policies. What are those? How do we implement it? And why do we implement it? And this is the last video in the topic security. And after that, we'll move on to storage. And then we'll be doing cluster installation, cluster maintenance, and troubleshooting, and so on. So there are still a lot of videos pending. In this video, there'll be a GitHub repository as always in the day 26 folder. And there'll be some task for you to complete. That will be enough for do the hands-on about network policies. I will also share all the important documents, link, and everything in the same repository, so feel free to check that out. And comments and like target for this video is 180 likes and 180 comments in the next 24 hours. Please try to do that, and I will see you soon with the next video afterwards. So without any further ado, let's start with this video. Okay, so before getting into network policies and everything else, let's quickly have a look at the network flow. Like, why do we even need it? So this will answer that question. So let's say we have three different tiers. So it's a 3-tier web application, right? And it has, I'll just write it down over here. It has a web tier. And then we have an application tier, app tier, and then we have a database tier, right? So consider this web application that is exposed over port 80 or 443, and then it has an application tiers which implements the business logic, and then we have a database tier which actually runs a database server, let's say MySQL. So I'll just add some details over here. This is the database, okay, and we have MySQL database running. Then we also have some application running. So this is an Nginx running on app tier or Node.js, doesn't matter. Like, this is just an example. So let's say this is an app, or we call it backend app. Okay. And the same way we have a front end app. In front end as well, let's take the example of Nginx. We have the front end app over here. Now, this application, because this is a web application, it's been exposed to the users on port 80 and 443. So this is the flow of user, right? And when user will try to access the application, let's say there is a service, a load balancer in between, but let's assume that we don't have anything like that. So it is exposed directly on the web tier, right? So user is accessing the front end application on port 80 or 443 or both of those, right? HTTP and HTTPS. And then this front end application calls the backend application internally, like to get some data, to do some processing and so on. So that will also do that on port 80. And then your backend application reaches out to your database tier to get some records and so on. And this will be done on the MySQL port 3306, right? So this is the flow where user is trying to get inside the application from outside, right? So flow is from left to right or from top to down, whatever you call it. So this type of flow that is going incoming, right? All the incoming flows to the application from outside is called ingress, right? This is the ingress flow. And when, let's say, your database records have been updated, your backend will get the reply back from the MySQL server. Then the backend will return the response back to the user with the help of front end, and user will get the response back. So this flow that is going in the reverse direction, that is going from your application to outside, this is your egress or outgoing flow, right? So incoming, and let me write it down. So this is outgoing, and this is called egress with the E. Now, this is just the flow. Now, let's consider this is not a 3-tier application, or if it is a 3-tier application, let's say it is not hosted on the application server, it is hosted on Kubernetes nodes. And these are nothing but nodes. So node A, so these are worker nodes, node A, and then we have node B over here, and then we have node C. Okay. The user that was communicating with the application, now the user is communicating with the help of API server. So let me add a control plane node over here. And let's search control plane or Kubernetes over here. Okay. And the user will be actually using the kubectl client or any client to call the API server. So now the user will call this. Okay. And rest of the flow will be same. It's just instead of applications, now we have pods running. Okay, this is an Nginx pod over here, and this is an Nginx pod, and this is a MySQL pod. Okay, so we have 3 pods running in 3 different nodes, let's say for example, and it's exposed because now we have to make the pods accessible. So we can access the pods with the help of service, because in service you cannot directly access the pod from outside the cluster, right? User has to go through some service, some load balancer, and so on. So I'll expose this service right on port 80, or let's use port 80 for now. Okay, so this service is exposed on port 80. Then similar way, backend is also exposed on port 80. Okay, let's remove this, and your database is exposed on port 3306 with the help of service. All right, let's remove these things now, make things more clear. Okay, so we have 3 pods running. Those pods are hosting some applications, front end, back end, and database. And those pods are exposed with the help of service on specific ports, right? Port 80, port 80, or port 3306. Now, with Kubernetes, as we have seen earlier as well in Kubernetes, all the pods by default are able to communicate with each other. So let me just add some arrows over here. So you can access this service from this port, from this pod, and this pod to this service, and this service to this pod, this service to this pod. So pod services, everything can communicate with each other by default in a Kubernetes network. And also your front end pod can also communicate with the database pod directly, or database service directly, both of those. And it is for the other way around as well, like both egress and ingress, right? Now, how it is implemented? It is implemented with the help of a service called CNI, or network provider, container network interface. This is responsible for making sure that pods are accessible within the Kubernetes cluster, and all the services and pods can reach to each other by default. And it deploys one pod on each of the nodes to make this networking possible. Now, this CNI, actually, there are different type of CNI providers that you can use. So we have, I'll just add some examples. So we have ViewNet, we have Flannel, then we have Calico, we have Cilium, and so on. There are a lot more. And you can use either of those. These are open source project, and these are Kubernetes add-ons. That means this does not come by default with the Kubernetes installation. Now, we used Kind cluster for the installation, and Kind creates its own CNI plugin. It's called KindNet. Okay, so which we'll be looking at afterwards. But these are the plugins. So let's say when we install that CNI, it actually, let's say we used ViewNet. So what it did, it actually created a pod of ViewNet pod in all the nodes. And through this pod, because this is deployed as a daemon set, it will by default create one pod each on all the nodes. It will make this networking possible, whatever you are seeing over here, right? So this is the default behavior that comes with the CNI plugin. All right. Now, let's say you have implemented this as a production system in your organization. This is an enterprise grade application, let's assume. So you need to apply certain rules, certain policies, and to make your pods only accessible to the service that actually needs it. Right? For example, your front end should not communicate directly with the database tier. Only the backend server should have access to the database tier. Right? So this connection by default, we have to restrict this connection. Now, these two lines should be removed. And how do we do that? We do that with the help of network policies. Right. So this is why we are learning network policies. This all, like whatever we have seen so far, this is just to make you understand why we need network policy. Okay. Network policy is to implement certain rules, certain policies, certain restrictions in your pod networking so that some pods can communicate with each other, but only those that should have the access, and not everything should be connected with each other by default. Now, this network policy are enforced by the CNI plugin that we have seen over here, right? But not every CNI plugin supports network policy. So, for example, Flannel over here and also KindNet that comes with the Kind cluster, and I guess Minikube also has KindNet as the default CNI. So these two does not support network policies. So if you need to implement network policy, you have to choose anything else: ViewNet, Calico, Cilium, and there are many more. Right. So make sure you understand this. These do not support network policy. Now let's go back. Okay, so here is my cluster that was running. So if I do kget pods on kube system namespace, I will see some pods running for the control plane components, and then I will also see something called KindNet. Right, so this is the CNI that comes by default with the Kind cluster that we have installed. So it has 3 pods running, and let's see if we do kubectl get daemon set hyphen all. So we see a KindNet as the daemon set, and desired is 3, so current is 3. So it by default created one pod for each of the nodes because it is deployed as a daemon set. And that's what we discussed, like how CNIs are implemented and deployed. Now, because this cluster only has the CNI enabled, and like with Kind, we have some limitations. We cannot really update the configuration of the cluster. We have to recreate it. So if we look at the config YAML that we have used in one of the previous videos to install this cluster, it has these details. So we have one control plane node and 2 worker node, and we have also exposed host port 30,001 so that we can use service, right, as the node port. Now it does not have any networking details, so it created the default CNI. Now let's have a look at this YAML. This is the updated one, and we have added one more field to it, which is networking, and it is at the same level of nodes, API server, and Kind. This is at the root level. So networking, and then add this property which says disable default CNI equal to true, so that the cluster will be created without the default CNI, without Kind, and we will install our own Kind, our own CNI. Okay, so let's use the command kubectl create cluster, and let's give this a name ck-new, and I'm going to use kind.yaml, the updated file. Okay, says ensuring node image, preparing nodes, and then it will install a storage class and other few things. Oh, it says driver fail external okay, because 30,000 port has already been binded by the other cluster. So let me delete this first. It should be kind Okay, client delete cluster hyphen name equal to ck. So this was the cluster. This will release the port. And now if I run this command again, okay, it says the nodes are ready. Starting configuration, starting control plane, then it will join the worker nodes with the control plane node to make it as part of the cluster and install storage class. Storage class will look into the storage section, don't worry about it. And then we have the last step. I guess this one is the last step, joining worker nodes. So should be installed fairly quickly. Let's see. Is it's done? Okay, and it by default switch the context. So if I do k get nodes, now okay, it's still coming up. Let's wait for a few more seconds. Still not ready. Let's add watch to it so that the status will be updated as soon as the nodes are ready. Let's see if there is any issue. So let's do a describe on the node. kubectl up here, kubectl describe node and node name. And it says registered with controller. So maybe it was just taking time. Still not up. I don't see any error till now. Just doing the check. Okay, I'm gonna pause the video till it comes up. So it's still not coming up. Maybe there is some issue. So let's do the describe on the node again. So let's do on any of the nodes, k describe node, and then the name of the node. And over here, I don't see any error. It says registered node, but if you scroll up, you will see the events. Let's go up and okay, over here I see some error. It says kubelet not ready, and that is why the nodes are not ready. It says container runtime network not ready because network plugin is not ready and it's not installed. CNI plugin not installed because we disabled the default CNI plugin and it requires a CNI plugin to be installed to create a fully functional Kubernetes cluster, right? So let's install this. Let me show you the documentation first. So here is a documentation page that we'll be referring. If you go up, it says the same thing that we have discussed. You need to configure a network provider with network policy support. And you see Flannel and KindNet is not in one of these lists because it's not supported. Right. So you can choose any of those. Let's use this one, ViewNet. And it says to install the ViewNet add-on, follow this guide over here. So let's go over there. It's a GitHub repository, and here is the daemon set YAML that we can use. So I'm gonna copy this and let's paste it over here. Okay, so it created a few things. It created the daemon set, the service account, the cluster role binding, RBACs, role binding, role and role binding, daemon set, and all of these resources. So now if we do kubectl get daemon set, should be in kube system namespace. So I'm gonna add that. Okay, ViewNet is installed, current 3, ready 3, and if I do k get pods -n kube system and let's grep View. Okay, we have 3 pods running and it has an init container. So both the containers are up and running. So we should be good now. If we do a kubectl get nodes now, nodes are also ready. So that is why it was preventing the nodes to become healthy because network was not available. Okay, now our nodes are healthy. We have installed the plugin. Now let's go back. Okay. Okay, let's do one thing. Let's use the same example that we did over here. So what I will do, I will create 3 deployments. Okay, one for front end, one for back end, one for MySQL database, and 3 services, one for front end, one for back end, and one for the database. And let's try to implement network policy on that. And what we'll do, we'll try to restrict this access because by default, all the pods should be able to communicate with each other with the CNI that we have installed. So by default, you should be able to reach front end to the back end and to the database tier, and we should restrict this access. This is where we need to implement the policy. So let's go back and let's first create the resources. We have a manifest over here. Let me show you the manifest first. Okay. So as I've said, it has a pod. Okay, a front end pod with the label as role equal to front end and name as front end. It has Nginx container running on port 80. Then we have a service that exposes this pod on port 80. And then we have a backend. And by the way, if I have not mentioned this before, you can have multiple resource manifest within the same YAML file separated by these three hyphens, right? So for example, the first this service ended over here. So we have added these three hyphen, and from the next line, you can add another manifest, another pod manifest or service manifest, or whichever resource you want to create. Okay. So the second one is it's a backend pod with the label role equal to backend, Nginx container running on port 80, and then service. Then we have a database MySQL running on port 3306, and we have a pod for MySQL. Right? It has some environment variable as well, and it is exposed on port 3306. Right? So if I apply this YAML, apply -f manifest. Okay, it created 3 pods and 3 services. And if we do get pods now, okay, it's still getting created. Let's add a watch in front of it. Okay, 2 are running. Oh, no, just, yeah, backend and front end are running, and MySQL is also running now. So if I do get pods now, they all are running. And if I do get service or SVC, I see 3 additional services. This Kubernetes is the default service. We have 3 more: front end on port 80, database on port 3306, backend on port 80, right? So same as what we have seen in the diagram. So we have created our infrastructure sort of to host our application. Now let's exec into one of the front end pod. Let's do a get pod. Front end name is front end. So kubectl exec -8 and bash. Okay, I'm inside the pod. Now do a curl on database service because service name is DB. And okay, let's do on the backend first. So the service name is backend and it is exposed on port 80. So you can directly do a curl on that. And I'm getting the response back. Like I'm getting the default Nginx web page over here. Now curl will not work in case of a database connection. So let's install the telnet utility first. apt-get update and apt-get install telnet, so that we should check if we have the port open with the database server or not. Okay, let's install it. Okay, now it's been installed. Now let's do a telnet for DB because service name is DB and port is 3306. And it says connected to DB, and basically we're getting the reply back. Okay, so now we are able to access from front end to database and from front end to backend. Now we have to restrict this access. Let's exit from the pod. And what we'll be creating, we'll be creating a network policy object. So you can follow along this tutorial as well. This is a pretty simple one with just one service and one pod. And basically what it does, I'll explain it over here. So you have an API version with networking, K8s IO v1, then kind is network policy, and then we have a metadata with the name. Then we have spec. Till here is the standard pod manifest. Over here, now we have to apply this network policy to some object. In our case, it's a service or a pod, right? So what we'll do, we'll add spec, pod selector, and match label. The same way we do for deployments. The same way we are matching labels with the label inside the pod. So pod has this label app equal to Nginx, and we are matching it, right? So it will be applicable to both front end, back end, database. I guess let's see what labels do we have. Manifest. Okay, So it's not for the pod, it's for the service, right? No. Oh, we are looking at both the separate examples. So don't worry about it. So let's take this example. So over here we have app equal to nginx, and let's see the pod that we created over here. Okay, so the deployment was nginx, so that means the pod has a label which called app equal to nginx. So that is why it is matching with that, right? And so here we are giving the reference of the pod to which we have to apply this network policy on. And then we write our ingress or egress rule. We can write both or we can write either of those. So let's say we are writing ingress. Okay. And then we are adding this thing from pod selector, and we are matching the label again, access equal to true. So what this is doing actually, it is matching the label access equal to true from the pod. So there is a different pod that is trying to access this pod, and only if it has the matching label, only if that pod has access equal to true, only then that pod will be able to connect. Okay, let's see the example that we were working on. So over here, we have our network policy YAML. Okay, same thing. We have name is db test, and then we have pod selector with matching label name equal to MySQL. Now, if you see in the YAML file over here, okay, here is our label. Okay, label is MySQL, which is matching with the label selector in network policy over here, right? So this is matching with the pod, and now we have specified policy type as ingress. Right? This could be ingress, egress, both or either of those, and this is an array, a list, right? And then we have provided the ingress details from pod selector match label role equal to backend. That means only the pod that has role equal to backend. So role equal to front end will be denied because we are not adding it. Only the backend pod will be able to connect to this particular pod with the matching label MySQL and on port 3306 only. And you can specify a lot of other details like namespace, resource name, and so on. You can check the examples. But for now, just look at this. We are restricting access from only one pod to this pod and only on a particular port, right? So if we apply this YAML, apply -f net policy.yaml, okay, it says it's created. And again, because it's a Kubernetes object, you can do a get on this, get net pol. Net pol is the short for network policy. And you see pod selector name equal to MySQL. And you can do a describe as well on this. Describe net pol name. And you see over here, it says pod selector name equal to MySQL. That means it is applied on the pod MySQL, and it is allowing ingress traffic on port 3306 from pod selector role equal to backend. Okay, this is self-explanatory, and it has the policy type as ingress, not affecting egress traffic. That means egress traffic will still remain the same that it was there before, right? We are not touching that as of this moment. Okay, now that we have implemented this network policy, let's exec into that pod again, front end pod. Okay, we are inside the front end pod, and let's do telnet on db on port 3306. Okay, I've made a typo, telnet. All right. Okay, now it says trying to the database service, but it's not getting any reply. It's basically going to time out after some time because we have actually blocked that port from this service. Now, if we go and do exit, and instead of front end, if we go to back end, okay, we are inside the backend pod now. And if we do curl, or not curl, let's do telnet telnet db pod 3306. Oh, we don't have telnet installed in this, so apt-get update and apt-get install telnet. Yes. Okay, it's installed. Now let's run the command again, telnet db3306. This should be enabled because we have allowed this backend to database access, right? So let's troubleshoot this. What is the issue over here? Says match label role equal to backend on port 3306. And let's go to the manifest. Name service name is DB. That's all right. And backend pod name is it's backend. Role equal to backend. Labels role equal to backend. And service also has the same label role equal to backend. Still, it's not able to connect. Let's see this network policy one more time. Get network policy applied on MySQL, and let's do a k describe on this. Says from pod selector role equal to backend. That's okay. To port 3306. Ingress. That means ingress on MySQL pod. Okay. So it should be able to connect. Okay, let me have a look at this one. So after spending a day in troubleshooting this, I was finally able to figure out the issue. So let me explain you what was the issue and how do we fix it. So if you see the CNI that we were using, ViewNet, it is out of date. Like the last commit on this project was 2 years ago. We can see that from the GitHub repository over here. And it's not been maintained properly. And now that we are using Kubernetes 1.30, it's either not been compatible with the Kubernetes version or the kind cluster setup that we are using. So that is why I decided to clean up everything and then install another plugin such as Calico on the same cluster. And it was throwing some error because the ViewNet was not cleaned properly. Just cleaning the resources would not help. You have to clean up some other files as well in the by going to each of the nodes, and you have to clean up some configuration data as well. So I thought maybe I'll create a new cluster and try it out. So I tried some other plugins as well, and this is the easiest setup that I found. So that's why I have used Calico, and it's one of the most popular CNI plugin these days. Plus, like most of the cloud providers are using this as the default CNI. So if we talk about GKE either uses Calico or Cilium. It's one of those. So yeah, so it's one of the popular that's we can use it without any issues. I will share the link of this page in the GitHub repository in the description as well. So they have a separate section. How do we set up Calico in a multi-node kind cluster, which is what we are using, right? So here is the kind YAML. So let me just copy it and I'm gonna create a new file. Okay. Okay, I've already copied it, so that's good. The only difference with this file is they have added the pod subnet range as well. So just to make sure that it does not clash with your existing subnet range, so that it keeps it separate, right? So that's why it has added one more property to it. So you can add this. And if you remember in one of the videos where we discussed services, we added this extra port mapping property as well. So keep this as well, and rest everything is same. Now, if we follow the document, what does it say? So once you have the file created, you can create the cluster using the kind create cluster command. So let's do that. Okay. Let's use the command kind create cluster and hyphen hyphen config will pass the YAML file kind calico.yaml hyphen hyphen name. Let's give it the name CKA. Okay. I have already cleaned up the existing cluster, so this should be the newer one. Okay, it will take a few minutes or few seconds and the cluster will be ready. Let's go back to the documentation and it says once it is ready, you can do get nodes to see the nodes are created. Remember, we have not installed the Calico yet. We are just provisioning the cluster for now. So your nodes will be in not ready status. And once that is done, once you see your nodes, you can install the Calico using either of these options. So we have the option to create it from operator and CRDs. We have not discussed operator and CRDs because it's not in the scope of CKA. But we'll cover that if we create a playlist of CKAD, or I'll create a separate video after we are done with this series. So I just want to keep the concept separate, and I don't want to mix things to, it will just confuse you. Yeah. Forget this for now. So we can use the manifest way. There'll be a YAML and you can check the YAML in the GitHub as well. So this YAML you can just apply and it will create a few resources for you. So you can see it will create a config map and many CRDs, cluster role bindings, daemon sets, service account, deployments, and so on. So it will create a bunch of resources. So let me just copy the command from here, and our cluster should be provisioned by now. Yeah, so it says everything is done. So if I do kubectl get nodes, I can see my nodes, they are in not ready status. That's fine. So let's apply Calico now. Okay, and that's it. It just one command setup installation. And if we want to check the status of the Calico, you can just run this command kubectl get pods, and there'll be a label which says k8-app equal to Calico node. So you can check that and it will be in the kube system namespace. So for that, I'm going to use -a. Okay, kubectl get pods -l, which is a label on all of the Calico pods. And remember, these pods are deployed as a daemon set. So it will place one pod on every single available node, right? And it says it's not up yet. So let's add --watch and it will update once it is ready. Or it is ready. It was fast. So 43 seconds. And all the containers are up. Now let's apply our manifest. Same file kubectl apply -f. So it will create 3 pods and 3 services. So let's apply this, and front end, back end, DB services and pods are created. This is what we have already seen. So I'm not gonna explain it now. And if I do get pods, it's still container creating -watch. Okay, it's running. Everything is running now. And if we do get svc, all services are also created. So let's exec into one of the pods, kubectl exec -it, and then let's go inside front end pod -bash. Okay, I'm inside the front end pod. Now let's try to curl any other endpoint. Let's do a curl on backend, right? Backend on port 80, because backend is the service, so we can directly refer it by the service name. It's a host name, right? So it is getting reply back, welcome to Nginx. It is returning the default Nginx page that is serving on the backend service port 80, right? So we are able to reach from front end to backend. Now let's see if we are able to reach from front end to DB. Now, because we cannot do a curl on DB, there is no endpoint exposed. There is a database MySQL running. So let's install telnet utility. So for that, I'm gonna do apt-get update and apt-get apt-get install telnet -y, so that it will not prompt me for yes or no option. Okay, it's installed. Now let's do a telnet on backend first. Telnet backend on port 80. Okay, it is getting connected. Now let's do a telnet on DB on port 3306, the port that we exposed for the DB service, and it is getting the reply back. That is also good. Now let's do an exit. And instead of front end, now let's go to backend. Okay, and do the same to install telnet. So apt-get update and apt-get install telnet -y. Okay, installed. Now let's do a curl from backend to front end, the other way around. Curl front end on port 80. Okay, it's getting connected. We are getting the reply back, and we are getting the default Nginx page. Now we have installed telnet as well. So let's do a telnet on DB on port 3306, and it is getting connected. Now that we have seen, we are able to connect from front end to back end, from front end to DB, and from back end to front end, back end to DB. So all ports are connected with each other. They are exposed. The ports are open. Now, what we want to do as part of what we discussed earlier, we want to restrict access to database from only backend pod. Only backend pod should be able to access your database on port 3306, and front end should not have access to that. For that, we gonna apply the network policy. Okay, we have already discussed that, so I'm just gonna apply it straight. kubectl apply net policy. Okay, it's created. Now if we do describe net poll, and the policy name was db test, I suppose. Yeah, so it says allowing traffic to port 3306 from pod where the label is role equal to backend, and it is not affecting egress traffic because we have only specified ingress traffic rules in the YAML. Okay, so this is good. Now let's go to our front end. Okay, and let's do a curl or telnet on db3306. Now, what should be the output? Earlier it was getting connected. This time it should be blocked. Okay, so it says it's trying, and eventually it will time out because the traffic has been blocked from front end to database. Now, if we do an exit and let's go to backend. Okay, now if we do a telnet db on port 3306, what should be the output now? We are connecting from backend to DB. This should be allowed, right? So if I hit enter, I'm getting the reply back. So this is what we wanted to do. If we go back to our diagram, where was it? Okay, I guess over here, right? So what we did, let me remove these. Okay. Now, earlier these all pods and services were connected. Now what we did, we actually allowed backend to database traffic. Okay, this was allowed, and we actually restricted front end to database traffic. Okay, this was restricted. So let me just change the color to red. So this was restricted and only this traffic was allowed. Okay, and that means user cannot directly access to MySQL pod, or any other front end pod or service cannot access MySQL pod directly. So only backend pod will have access to connect to MySQL. Let's say if we have another service running, okay, somewhere in the cluster, let's say on this node. So this by default, whatever we create as a new, this by default would not have access to the database pod. So this access will also be restricted, right? So this is one way of implementing network policies. Like there are, this is just an example, and we can do it a lot better, right? In a production grade environment, we actually have default deny rules. So what we do, we first create a default deny rule. So to deny every single traffic to every single pod. So that means all the pods are not connected by default. And then we only allow the traffic that we need. So we create rules one by one and we grow from there, right? So that's what we do. And yes, there'll be examples task in the GitHub repository of this video. So in that, we're gonna do a little more than this, and I hope you were able to get the idea. And so try to install Calico. Calico works perfectly fine. We have just seen and the documentation is pretty straightforward. You can follow along. Don't go with ViewNet if you are using Kind or any other, because ViewNet it's really old plugin, and it's not really been updated quite frequently. So I would not suggest going with that. Go with either Calico or Cilium. Cilium I have not tested, but Calico I just did, so it should be good enough. Okay. Alright, so that's it about this video. I hope you have learned something out of it and you were able to implement everything that we have discussed in the video. There'll be a task in the GitHub repository. Try to complete that as well and let me know in the comments and in the Discord community if you face any issues. If not, please try to complete the comments and like targets. I would really appreciate that, and I will see you soon with the next video. And this completes our security section, and we'll be starting with the storage section from now on. So thank you so much, and I wish you have a good day.